right, good afternoon, everyone. I want to welcome everyone here to Improving Talks. We are now in week 2 of our Unlock the Value series, and we're thrilled to continue this journey of exploring cutting-edge technologies that can transform your data strategy. Today's session focuses on building a modern data ecosystem with Databricks and Confluent. Before we dive into this fascinating topic, I'd like to introduce our speaker who's leading the charge in turning data into actionable intelligence. Scott joins us today as the Director of Machine Learning and Artificial Intelligence, bringing a wealth of expertise that extends far beyond his title. While his primary focus is on ML and AI systems, data engineering, and backend development, Scott is truly a versatile technologist with full stack capabilities across multiple front-end frameworks. What makes Scott particularly valuable in today's data-driven landscape is his passion for automation and efficiency. He has a remarkable talent for streamlining both code and business processes, helping organizations eliminate bottlenecks and maximize productivity. His extensive background spans various industries and technologies, giving him a unique perspective on how data solutions can be tailored to specific business needs. Today, Scott will be addressing one of the most pressing challenges facing data-driven organizations: how to develop a platform that efficiently handles both batch and real-time analytics at scale. In a world where data is recognized as a strategic asset, this capability has become nothing short of essential. The insights Scott will share today aren't just theoretical, they're proven approaches that can help transform your organization into a true data-driven powerhouse. Whether you're looking to enhance your existing data infrastructure or build something new from the ground up, you'll walk away with actionable strategies you can implement right away. I encourage everyone here to use the Q&A feature in Zoom to submit your questions throughout the presentation. I'll be sure that Scott sees them at the end of his talk and he can address them. This is your opportunity to tap into Scott's expertise and get answers to your specific data challenges. So, without further ado, please join me in welcoming Scott to the virtual stage.
Thank you, Daniel. Appreciate it. Appreciate the warm welcome. I appreciate everyone coming to see me talk today. It's always a pleasure to share what knowledge I have in this space. But yeah, today we're going to go over the empowering a data-driven future, really looking into this aspect of harnessing Databricks and Confluent for a modern data platform. It spans the aspects from exactly what Daniel was saying, from the aspects of batch to real time, and how to really push both platforms together at the end of the day to enforce this aspect of a modern day platform. So we'll skip my introductions real quick because Daniel gave an awesome introduction. So jumping right into it. So the big thing here, I like to call this the aspects of the data imperative. But why do we call it this data imperative? Mostly just because data has become a strategic asset inside of most organizations, just not an operational byproduct or something that's being collected over time. Most leading companies recognize that data is key to staying competitive, and most organizations are moving that way as well. Outside of that, whether it's identifying new revenue streams, improving operational efficiency, enhancing customer experience, it just really grows in this aspect of data has become such a vital aspect of our business. However, the complexity of data is ever growing. We have, just due to the aspects of the big data era, we have massive volumes of both structured and unstructured data that come in a whole bunch of different areas and various sources, from IoT sensors or web applications, legacy databases, SAP, Salesforce, you name it. So there is a never-ending stream of data, kind of a shout out to Confluent there with streams, but the aspects of just the sheer quantity of data is ever growing. And the nice part about this is there are tools out there to help us. So the biggest thing right now is you have a lot of demands coming beforehand. When all of this data was coming into play, we had systems that helped us do batch analysis and nightly, weekly kind of batch processing, and allowing customers to see things more on a day or month basis. But now, with the ever growing competition of implementation of different technologies, it's becoming more apparent that we need a lot faster insights, even up to the minute aspects of intelligence. For example, financial services platforms want to personalize user experience the moment they log in, or financial institutions want to detect fraud the second it happens. Traditional architectures typically can't keep up with this, and a lot of legacy solutions might not be built to handle streaming data or any kind of scale that comes into play with large batches of data or the massive volumes of data. And so this is where we effectively need to modernize a lot of our solutions. And most companies are moving towards this direction. And there are still some that are going through the efforts of doing so. But this is kind of where Databricks and Confluent really comes together to kind of provide you, I don't want to say a one-stop shop, but like effectively a large gap or a large combination of what you effectively entail with the data platform. So Databricks provides that unified kind of analytics platform. Often it has this term that they commonly use called lakehouse. And it kind of brings the best of both worlds of data lakes and data warehouses. And so it really helps with the aspects of scalable data engineering, analytics, machine learning. And with the Databricks platform, which is really nice, is the collaborative data science platform aspects. And then on the flip side of it, with the Confluent, is it provides an enterprise streaming platform, all built on Apache Kafka, but it's taken almost to the next level with the Confluent implementation. You get the simplification of real-time data pipelines, management of schemas, seamless integration with a bunch of different systems, a whole suite and collection of different toolings to really enforce your Kafka implementation. And so Confluent is really powerful here and has a bunch of different integrations now with Databricks to kind of push it even further. So this really bridges that gap between your operational data flows and your analytical insights, kind of give you a holistic picture of how does the operation side and non-operation side come together to provide me insights as we move forward into the future. So I like to kind of jump into one of our clients that we helped in this space with both Databricks and Confluent. Kind of jump into what we've experienced with them. We'll first kind of go high level overview of the various aspects that we helped in those areas, and then kind of Databricks in itself and in general aspects, and then talk about the growing aspects and cases, the use cases that we have for both Databricks, Confluent, and then kind of bring it all together at the end. So jumping into the Databricks side of it, one of the most common places that we've seen this, and an easy, sure way to implement like a lot of different solutions, is in the financial services space. Granted, it's not just capped to that, but it is definitely a good area where we've seen a lot of effort in this space as well. But the biggest things here that we've kind of pushed for is the aspects, and especially with our large financial services company that we effectively worked with, it was mainly around their non-operational data. Due to compliance reasons, there's a bunch of different regulatory reasons. There was a bunch of reasons why we couldn't combine some aspects, but Databricks as itself as a platform enabled both high-level analytics and machine learning capabilities to kind of enforce and allow them to do next level like predictions and analysis and decision making with their machine learning capabilities on Databricks. So allowing us to kind of go down this path of utilizing Delta Lake is kind of one of the big things that we drive a lot of our clients to, especially when they're on Databricks, or like in the 10 years that I've been effectively looking at Databricks and doing stuff with Databricks. It's interesting to see the progression and movement of the usage of Databricks. So you start with typically a lot of clients that were in the older generation of Databricks, they weren't on the Delta engine or Delta Lake. And so or Unity catalog. And so it's a lot of conversion to that. And there's a lot of optimization you get out of that. Kind of look at that here, because this is the high level overview of all the big things that I think Databricks really brings to the table when it comes to you going towards a unified data platform. Delta Lake in itself, and we've actually done a lot of analysis and benchmarking comparative to a lot of other major tools. And the utilization of Delta Lake and Delta Engine together actually shows very high performant and cost efficient data processing at scale comparative to a lot of its other competitors. And I'm also very happy to talk about that at another time, because there's so much that goes into that. But as it stands, it is such a high performance solution, and that is super helpful for the aspects of both analytics and machine learning at scale. So if you think about it, one of the biggest things that in machine learning, when you're training a model itself, is the time that it takes to get data from storage up to compute is typically very slow comparative to backbone solutions that are on GCP, Azure, and AWS. The nice part about Databricks and Delta Lake is that you also get that hyper speed up with how your data is effectively stored on their solutions and put into memory for training purposes. And so the nice part here is that you get that Delta Lake aspect, the Lakehouse analytics aspects, and then the high scaling of compute and being able to train machine learning at significant higher scales. On top of that, they have a bunch of collaborative notebooks, unified governance. The Unity catalog in itself is probably one of the most valuable tools that you can effectively implement when setting up Databricks, simply due to the aspects of not just from a data perspective and a data governance perspective of controlling your data, managing your data, who can access it and all that, but it moves it that much further into the machine learning realm of things as well, with being able to control and understand assets, where they are located. How do I pull them all together and put them into a downstream pipeline to effectively build high quality machine learning solutions? So Unity Catalog is more than just from a data governance perspective. It moves outside of that and grows into the machine learning realm significantly. I highly recommend, if you're going to put Databricks into your organization, utilize Delta Lake format and Unity Catalog to make sure that you are building the most efficient and most advanced Databricks implementation. So something that we always highly recommend to individuals as they move forward with a Databricks solution. So going into the aspects of machine learning and AI, there's a bunch of different things that we've done in this space with a lot of our clients, specifically in the case with our large financial services clients. We helped do a huge analysis around their machine learning and how to optimize, both from the standpoint of creation of models, management of models, and deployment of models. That was kind of like the biggest, I would say, one of the major efforts that we helped out outside of Delta Lake and Unity Catalog conversions. Inside of this space, the nice part about Databricks is that they are ever growing and making their solutions better. I remember way back in the day that deploying models on with Databricks and MLflow aspects, there was kind of this limitation of how fast, or something that's called queries per second, which is just a metric that's used to identify how fast can my machine learning model respond to a request. And so that metric was relatively low in the very beginning. Now it's at the next level of being able to compete with some of these major cloud providers. And so with that, it makes it nice. So now I can have a single unified solution, both from a modern data platform, and then that enables the machine learning platform to go forward and do everything else. So this is one of the biggest things that I think that Databricks has that makes it super capable of making a full end-to-end platform to drive those insights, not only from an analytics perspective, but from a machine learning perspective. And then eventually bridging into AI. They have a bunch of different AI tools that are coming out. They have a bunch of large language model integrations. It kind of just goes on and on from there. But the biggest thing here is that, and we'll get into this a little bit later, is that one of the biggest problems, I would say, in machine learning is from the data perspective, is that if I have real-time updates, how do I get that into my platform? How do I engage that with my inference that's being made at the API level? How do I make that from a batch perspective, and making sure those updates are real-time and the most accurate representation of data at that point? And beforehand, there was a way to do it, but it was very difficult and it wasn't as streamlined as it could be. Luckily, with the partnership between Confluent and Databricks, this has changed, and we'll get that to here in a bit. But to start off with, some of the use cases we really looked at as well was mostly around this non-operational analytics aspects, and machine learning around that as well, to kind of drive aspects of both from a reporting, a risk management, and client personalization as well. So those were the big areas, utilizing non-operational analytics to drive all these other features from a machine learning perspective. And so what drives all this need outside of that? Yes, I have the data platform and machine learning platform, but why would I need this from a business standpoint? The biggest thing here is that AI is driving significant competition amongst different industries. And so with that, having better machine learning and AI solutions that are fed from a holistic data platform is kind of key. And so with aspects of personalization, I think this is probably one of the biggest things that are out there that impacts different types of services environments. If you provide a service to an individual at the customer basis, your experience with that solution is what kind of drives whether or not you stay with a certain particular solution or service rather. So the biggest thing here is that how can we drive better personalization aspects and make them ever grow with our clientele? And so you need a lot of real-time, batch basis, and large quantity scale manipulation of data and handlement, which is kind of where this kind of partnership comes hand in hand to build a solution moving forward. And so that's honestly what really drives everything is just this aspects of AI competition, the personalization aspects, and then real-time insights. Additionally, regulatory compliance can both hinder and help. In our previous client, it definitely was a hindrance in some aspects just due to the fact of what data was where and what can be used. So from a Confluent perspective, and this will be a kind of a high-level overview of Confluent in itself at first, and then we'll kind of dive into where our client effectively utilized Confluent to make themselves more efficient, both from individual application aspect and then from an enterprise scale. So looking at it, so Confluent provides a lot of really good toolings. My favorite, honestly, is this aspect of full schema control, although it can introduce a lot of complexity depending on what you're trying to do, but there's a lot of different design patterns and frameworks that you can put in place to make full schema control a lot more simpler. And it just depends on how data comes in and how you migrate it and move it and all that stuff. So the biggest thing here is that knowing that when I send a message in, that it'll be fully accepted, and the message out is exactly what I expect. I remember back in the days when I didn't have full schema control, just using standard Java messaging services. This was the biggest pain, is receiving a message that I had unknown bodies for some reason and having to deal with that. And so that's one of the nice things about Confluent Schema Registry is it just allows you to control that and know for sure fact that my service that is reading this message broker is going to receive the proper message from that queue. And so it alleviates a lot of pain, if you ask me. On top of that, there's a bunch of other pieces that allow you to do like replayability, making sure that it's secure messaging, and there's a bunch of different secure like message security protocol aspects that you can do with it. I've been only exposed to like two of the many of them, but the two that I used were very efficient. One was a little bit painful with having to deal with different types of credentials, but there's also other aspects that you can use that make it significantly easier. That being said, Kafka and with Confluent and Kafka, this is probably one of my favorite tools to use just due to the fact that it allows you to control data more efficiently. And it also empowers a lot of machine learning design patterns that exist out there today to enable your machine learning models to make the right prediction at the right time, especially if you have a real-time API aspect. So we'll get into a little bit more of that here a little bit later. But so from our client's perspective, there was effectively something we're going to call their integration services vision. So this is the aspects of their integration platform and effectively allowed them to drive enterprise APIs and connect them all together. So all of their data lived in a data platform or in their core business systems, and they wanted to bring an integration aspect so that way they can enable all of their different systems to enhance their different types of experiences, both from a client, advisor, or service and operations aspects. So this was kind of the vision for the platform itself. And so their old experience was effectively that they had a bunch of different services and the systems all engaged with different types of core business systems. And it just kind of was a mess. It was very difficult to organize and control. And their hope was to build this integration platform together to provide kind of a separation between the engagement systems and the core business systems themselves so that there was a unified place for them to go to and retrieve information that is needed, made integrations a lot more simpler, and just increased performance and durability of the systems themselves. So moving into the aspects of streaming architecture. So this was effectively a very rudimentary aspect of what the structure was and how effectively it moved. So it allowed for various different types of connections where the source of record fed either into a Kafka topic or it came from the Kafka Confluent platform into a replication. So like if you had an on-prem system that and it was air-gapped from a cloud system, you can effectively create a replicator that replicates stuff from on-prem to the cloud. There's also aspects for data that's moved from sources of records for utilizing like the Q-Lake replication, so it's just moved straight over. There's also other queuing services. How do you connect that, move that over into Confluent Cloud? And there's also things like change data capture aspects as well for databases that move things up there as well. And just allowed us to move everything into this aspect of stream and connectors and put this into both from an event basis or an API basis utilizing various other data tools. That being said, kind of want to move into this aspect of what the future looks like with Databricks and Confluent. I mentioned earlier that with our large financial services company, that they had a regulatory reason why they couldn't combine Databricks and Confluent. That being said, once that is surpassed and they find a way to utilize it else or find a ways to use it in their own separate areas, they can extend into utilizing a bunch of new tools that have been come out. So one of the big things that definitely want to call out here is that the integration in action aspect is this. Now we have real-time data ingestions unifying with data pipelines on the Delta Lake side and move into real-time analytics and machine learning and allows for better operational intelligence. And how this is done effectively is that they released very recently a Confluent integration between Tableflow and Delta Lake. And why this makes sense from both an analytics and machine learning perspective is that now you can have streamed events be represented inside of your Unity catalog in Delta Lake more quickly. So there's less of a lag time between the time that I receive the data until it's inside of Databricks and my large aggregate of data, which allows us to make better analytical decisions and then also feed machine learning solutions and make them more efficient as well. For a specific case I mentioned with the Unity catalog, it is heavily, a lot of machine learning solutions can be very dependent on Unity catalog. And so having the most representative of data at that point in time is kind of useful, especially to avoid something called what is called the training serving skew. And this is a common pattern that occurs with inside of machine learning. What happens is at the time that I train a machine learning model, I have one version of the data. And then at the time that I go to make a prediction, an alternative version of that data appears, which results in a bad prediction and which results into potentially a bad decision. And so with utilizing Tableflow, Delta Lake, and Unity Catalog, you get the most representative data at the time of training something, and then also at the time of making predictions. So that way your machine learning model is getting the same representation both times. And that way you get a better prediction at the end of it, which allows you to make a better decision. So this is one of the biggest things that I think that Confluent and Databricks have brought together that really enables, especially in the space for real-time analytics and machine learning, and from a data perspective. Now we have a better representation of our data inside of our lakehouse and how to move forward with that into the future. And so technical implementation here, just a little bit on it. So they have the Confluent Tableflow, which allows us to convert Kafka streams into Delta Lake tables, which allows us to also put it inside of Unity Catalog. Allows that bidirectional data flow between them with the feedback that comes back into the operational applications or non-operational applications if you have segregated systems. So they have a bunch of different connectors allow you to quickly connect to different types of systems as well that do real-time and analytical aspects as well. So the big thing here to understand is that Confluent and Databricks have now provided a kind of almost a critical feature that allows us to go from beforehand, it was a lot of the streaming data tables that we would have to ingest with various different types of workflows, get that into nice massaged ways so we can feed it into the Delta Lakes. Now they provide Tableflow, which just helps us convert that and skip all the other steps and makes it easier from the standpoint of management from a topic representation of the data and how that's ingested into Databricks and held and moved into the future. So the big thing here is that it's just adding this such huge operational efficiency to allow you to make better decisions more quickly. So in summary, combining both the strengths of Databricks and Confluent, you achieve real-time insights, making decisions based on live data and not stale data, and then advanced analytics using collaborative notebooks and auto-scaling and machine learning libraries in Databricks to develop your models at scale with the most representative data that you have. And then it also, on top of that, helps reduce those data silos. So now that as a business, I can use my Databricks platform to make decisions on large scale data from both non-operational perspectives and operational perspectives. And then on top of that, the stronger governance and reliability. So the big thing here is Unity Catalog, which is probably the biggest aspect of Databricks that is around data governance and machine learning governance as well. And then on top of that, combining that with Confluent Schema Registry allows for a clear data lineage across your data platform. Ultimately, these integrated solutions help with accelerate digital transformation while lowering your operational complexity. So just really driving forward with the aspects of what my data platform can do to enable other aspects like analytical and machine learning and AI. That being said, if you want to learn more, you can go out to this website. We have a bunch of case studies that are out there that you can understand the aspects of Confluent and Databricks that is outside of, I believe, the use case that I talked about today. So that is all I have.
Hey, Scott, we do have one question that's come in.
Perfect.
As Databricks also provides real-time streaming, how is Confluent differentiating itself?
For sure. So one of the big things here is that Delta Live Tables is effectively their streaming capability, right? And there's a time and place as to when to use that. The nice part about Confluent is that it not only it provides you that streaming capability for Databricks, but it provides you the streaming capabilities for everything outside of there. So that way you're not solely dependent and figuring out a way, how do I get my data out of the streaming capabilities of Databricks to everything else? Because Confluent can just easily integrate, and a lot of people have already integrated with Confluent from a streaming perspective. It just allows and enables that. And why would I choose? My guess is the question will transform into why would I choose the Confluent platform over the Databricks platform from that sense? I would say that it has to do a lot with replay, a lot of the features that come out of Confluent. So the big things for me that I've noticed when building with applications on Confluent is that replayability aspect, what makes it easier to just go out and play a new set of streams and get new data from one side to the other and reprocessing and all that stuff. So I would say that it's significantly easier to do in that sense with Confluent, but I'm not saying that it's difficult to do with Databricks' Delta Live Tables. My personal preference is that with Confluent, it's significantly easier. And combining those two together just allows you to also have your non-operational and operational aspects separated. So a lot of times that we've seen is Databricks is only hosted for non-operational events and not processing operational events. And so it allows you to bring those two together. While Confluent is more on the operational side, your various transactions, communications between applications and a bunch of other things. Now you can kind of peer into that environment with Databricks and make new decisions based off of the data that's being streamed in. So there's a bunch of different design patterns and like scenarios in which Databricks and Confluent work really, really good together. And it's a larger conversation, I guess. Hopefully that answers your question.
Now, how do you compare the analytics capabilities between Databricks, which doesn't seem very mature, versus Confluent?
Interesting. I would argue a little bit different from the aspects of Databricks is analytics capabilities are just as good as the individuals trying to write the code to do the analytics.
Okay.
From the streaming aspects of Confluent, I know Confluent has a lot of different abilities to put conversions on the streams themselves and apply analytics in the sense that it makes conversions for downstream things to make decisions on. But the combination of the two together, I would say that brings the two to like move forward as like a kind of a powerhouse in the sense of analytical decision making and machine learning.
You're saying best of both worlds kind of thing?
Yeah, exactly.
think that's it for questions. Oh, we've got one more. Let's
Perfect.
see what this says. Has improving worked with stream processing for aggregations, joins, and transformations in conjunction with Databricks?
So yes. So before TableFlow, we've definitely had to do this in a sense for machine learning aspects. And so one of our clients effectively had a machine learning solution. A lot of their data was inside of Kafka or in Confluent Kafka. And so we had to set up all the different connections with Databricks beforehand through there's a series of code that you put in place so you can get the streaming data into Databricks and you can process it both from a real-time perspective and from a batch-based perspective. And so once we did that, we had to do the transformations and aggregates and windowing and all that stuff effectively with different types of workflows and a bunch of different types of applications to do all this stuff. There was also the level of effort to put applications beforehand into it was significantly less too. So we thought about doing both. But for the biggest part about Databricks is that it had the integration with all of the rest of the data that we needed. And so the Kafka representation only provided us half of the story that we needed at any given point in time. And the rest of it came from historical representation. And so when we built a lot of these aggregations and joins and separations and transformations effectively, we had to store that and put that into place. And so we used Databricks as that kind of engine. So we ingested all this information, combined it with other data from our historical record, did all the different transformations and made it available as a data set for machine learning and analytical purposes. So it's definitely one of our fortes, I would say. It's just that we've been exposed to it many, many times before. So there are good ways to do it. The nice part about the new TableFlow stuff is that it kind of helps alleviate the pain of this first part of having to set up all these different connections with Confluent Kafka and doing XYZ and managing all of that with all that data just streaming in and getting into the Delta Lake tables as themselves. It makes it that more efficient to manage and move forward with. Great question, though.
Yeah. Well, I think that might be the end of the questions. I don't see any more coming in. Do you want to let people know how to get in touch with you?
Yeah, feel free to reach out. I should have probably put my email in here. I apologize. It's scott.poulin@improving.com. If you have literally any questions, and I mean literally anything, please, please, please email me, and I am more than happy to answer your questions. You could be from our company or you could be from any other company. I'm happy to answer your questions. My biggest thing is I'm always happy to help. So,
And I will agree with that, having known Scott for about a year now. Yes, I want to thank everybody for joining us. Thank you, Scott, for this great talk about Databricks and Confluent. I'm sure it's going to spark a lot of questions in your email. So yeah, keep your eye out, and
love it.
we might have to have follow-ups or something like that. I want to thank everybody that submitted questions too. Your participation enhances these sessions for everyone. And now let's look ahead to week 3 of Unlock the Value series. We're going to be welcoming Mark Sewell. Mark will discuss transforming production lines using IoT insights. He'll share how a leading healthcare technology manufacturer broke down data silos to improve operations and enable predictive analytics. Mark's presentation will include technical best practices, key decision points, and real-world lessons learned. Both businesses and technology leaders will find practical takeaways for their own IoT initiatives. Thanks again for joining us here for this week 2 of the series. It's been a lot of information to absorb. I hope to see you next week for Mark's session. I want to wish everybody a great day, and thanks for joining us.